Good morning, students. First video physics in the first chapter of the class start B batch. Just 2 class repeat method class video watch first of all. Then text again watch the video, looking through the textbooks. Notes prepare class regular class notes class prepare text class class next time class speed but you can learn because already you have some idea. So for the B batch as well as A batch, I am starting the chapter. Combinedly I am starting the chapter 10, light, reflection and refraction. Regarding the nature of light, there were 2 theories. One is Newton's corpuscular theory and the other is the Huygens theory. Please, you verify the camera, please. Hello? Just see whether it is running. It's okay? Okay, let me continue. Newton's corpuscular theory, I'll write it here. Newton's corpuscular theory deals with the property that light from a luminous body is propagated in the form of minute particles. A corpuscle means a small particle, minute particle. So this is the theory of Newton. The path followed by a particle is called as a ray of light. We call it as a ray of light. Based upon this theory, Newton was able to prove the properties like reflection, refraction, so many properties. And another theory in light is Huygens wave theory. Christian Huygens is the full name. Huygens wave theory. The wave theory deals that light from a luminous body is propagated in the form of waves, not particles. So later, it was identified that light is having a dual character, means it behaves like a particle as well as behaves like a wave, both. This theory is accepted and those properties of light which can be easily explained on the basis of corpuscular theory are included in a chapter called ray optics. And those properties of light which can be explained easily on the basis of the wave theory are included in the chapter wave optics or wave optics. The other one is also called as geometrical optics. Newton's ray optics will be called as, otherwise called as geometrical optics. The other one is wave optics. Wave theory is the quality or the explanation method for the whole properties of light under this category. Now, we are learning only the ray optics and the wave optics will be studying only in your higher classes like 12th standard, not now. And we know that the property of reflection. Next we have to study first the property what you have studied, B batch studied already, reflection. What is reflection? When light is incident on a smooth surface, a polished surface like a mirror, the path of the light get deviated. This is called as reflection. So, if I represent this by a plane mirror, when you represent a plane mirror like this is the reflecting side. This is the non-reflecting side. When the light ray is incident on a plane mirror, it is getting reflected like this. This is called as incident ray. This is reflected ray. And if I draw a normal here, this angle is called angle of incidence I, and this angle is called angle of reflection R. I is angle of incidence and R is angle of reflection. This is the property called reflection. So when light undergoes reflection, it obeys two laws, which we call it as laws of reflection. The first law is the incident ray, the reflected ray and the normal should lie in the same plane, law 1. Law 2 is the angle of incidence equal to angle of reflection. That is I equal to R. I repeat, laws of reflection. 1. The incident ray, the reflected ray and the normal drawn at the point of incidence. This point is called point of incidence. The incident ray, the reflected ray and the normal should lie in the same plane. And the second law is the angle of incidence equal to angle of reflection. These are the laws of reflection, which is obeyed in any kind of mirror. Whether it is a plane mirror, concave mirror, convex mirror, in all the mirrors these properties are obeyed. Now, what are the properties of the image formed by a plane mirror? 4 properties. By heart these properties. 1. When a mirror reflects an object, what are the properties we see? 1. The object distance and the image distance are equal. Meaning, if this is the mirror, I keep an object here, I get an image here at the same distance. This distance is equal to this distance. That is, the object distance is equal to image distance. Property 1. 2. The image undergoes a lateral inversion. Lateral inversion means your left hand appears as the right hand. Nothing else happens, only your left hand appears to be the right hand. This is called as lateral inversion. It is called lateral inversion. This is the second property. Third one, the size of the object and the image are the same. The size of the object and the image are the same. Fourth one, the image formed is virtual. The image formed is virtual. Virtual means an image which can be seen only but cannot be focused on a screen, cannot be obtained on a screen. Real image is one which can be seen as well as can be focused on a screen, whereas virtual image can be seen only, cannot be focused on a screen. What are the 4 properties? 1. The object distance and the image distance are equal. Number 2. The image undergoes a lateral inversion, which means lateral inversion means the left side appears to be right. Third, the size of the object is same as the size of the image. And 4, the image formed is virtual. Virtual means the image which can be seen only but cannot be obtained on a screen. If you are keeping a screen behind a mirror, plain mirror, you will not get an image. Only you can see the image. When you stand in front of a plain mirror, you can see your image, but that image cannot be obtained on a screen if you are placing a screen behind the mirror. So this type of image is called as the virtual image, which can be seen only. Hope you understood that. Now, let us move further. There are another type of mirrors, hope you would have studied in elementary classes, 7th or 8th standard. Spherical mirrors. We will study today the details of spherical mirrors. Mirror which is concave or convex are called spherical mirrors. If the mirror is curved inward, it is called as a concave mirror, like this. This is a concave mirror. This side reflects light. And if the mirror is like this side reflects light, it is called as a convex mirror. This is concave mirror and this is convex mirror. They are combinedly called as spherical mirrors. Commonly, spherical mirrors. Concave mirror, convex mirror. Now study certain properties. The center of the mirror, always this mirror is a part of a sphere. You can draw a sphere completing this mirror. You can form a sphere. The center of the sphere in which the mirror is a part. If I draw it completely like this, you can see the mirror is a part of a sphere. The center of the sphere in which the mirror is a part is called center of curvature. Center of curvature. Center of curvature. And the radius of this sphere, this radius, is what you call as the radius of curvature. Radius of curvature. This is center of curvature. And radius of curvature means the radius of the sphere in which the mirror is a part is called as the radius of curvature. Then, the geometric center of the reflecting surface is called as a pole. If this is a mirror, the center, geometric center, is called as a pole of the mirror. Now, the distance from pole of the mirror to the center of curvature, that is the radius of the sphere. The distance between the pole of the mirror and the center of curvature is called as the radius of curvature. Radius of curvature. Radius of curvature. Okay. So what are the points? Center of curvature of the spherical mirror is the center of the sphere in which the mirror is a part. The geometric center of the reflecting surface is called the pole. P-O-L-E, pole. Pole of the mirror. Pole. P is the pole, the figure. Geometric center. The radius of the sphere in which the mirror is a part, this radius, is called as the radius of curvature. R, represented as R. Distance between pole and center of curvature is called as radius of curvature. It's the radius of sphere. It's true for convex also. Convex mirror also, the same thing is true. This is convex mirror, The sphere, center of curvature, pole of the mirror, radius of curvature, everything same idea. Hope you understood the meaning of these terms: center of curvature, radius of curvature, pole of the mirror, distance between pole and center of curvature is called as radius of curvature, and so on. Okay? Now, next is something about the focus. What is meant by focus, or otherwise called as principal focus? Let us see principal focus of a mirror, concave or convex mirror. Focus, I call it as focus, or I can call principal focus. Principal focus. In short form, we call it as focus. What is focus? Consider a concave mirror. I'll draw it for convenience like this. There are certain rules that you have to draw it like this. This is concave mirror. Suppose this line drawn from pole to center of curvature. Pole to the center of curvature. If you draw a line, it is called as principal axis. The line is called principal axis. What is principal axis? The line drawn from center of curvature to pole is called the principal axis. Always by convention, we draw light ray coming from left to right. I will explain it later. So this is a concave mirror. Suppose a parallel beam of light is incident. A parallel beam of light is incident on the mirror like this. A parallel beam of light. After reflection, they will converge to a point like this. After reflection, they will converge to a point. This is the incident by a parallel. After reflection, they converge to a point on the principal axis. They converge to a point on the principal axis. You can see this point is called principal focus of a concave mirror. Principal focus of a concave mirror. Here if you place a screen, you will get a diminished image, very small image. Okay, a concave mirror, you can face it to an object, external object, and you can form an image on the wall. That will be a diminished image. If the image is clear, it will be a diminished image. The point is what the focus. Once again, a parallel beam of light close to the principal axis, after reflection from the concave mirror, converges to a point on the principal axis. This point is called the principal focus of a concave mirror. Once again, a parallel beam of light close to the principal axis, after reflection from the concave mirror, converges to a point on the principal axis. That point is called the principal focus of the concave mirror. It is a real focus, means you can get an image there. Keeping a screen, you can get a diminished image. Now, the distance between pole and focus is called the focal length. PF, the distance PF is called as the focal length. It is called focal length. So hope you understood radius of curvature as well as focal length. This distance is called focal length. There is a relation between radius of curvature and focal length that R equal to 2F. It's always true for a spherical mirror. R equal to 2F means radius of curvature will be always double that of focal length. PF, PC, when you see PC is radius of curvature, PF is the focal length. So focal length will be double of focal length will be always the radius of curvature. This proof not needed. In higher classes in plus 2 only we will be studying the proof of this property R equal to F. So in a problem, if it is mentioned, the radius of curvature of a convex mirror, convex or concave, both, this is true for both, not true for plane mirror. If in a problem it is mentioned, the radius of curvature of a convex mirror is 40 centimeter, the radius of curvature will be 20, half of that. If the focal length is 10, then the radius of curvature will be 20. You can take it in problems, you can take this property, radius of curvature is twice focal length. So these are the fundamental studies. Now this much everybody would have seen. Now one more thing I will explain. This is concave mirror. How will you define the focal length of a convex mirror? Like this. This is a convex mirror. Principal axis. Okay, a narrow parallel beam of light close to the principal axis. After reflection from the convex mirror, what will happen is that it will appear to come from the focus. Appear to come from the focus. The reflection will be exactly like this. It is reflected like this. You can see a narrow parallel beam of light close to the principal axis after reflection appeared to diverge from the focus behind the mirror. If you are looking from here, you can see an image here, but behind the mirror. Looking from here, you can see an image behind the mirror. So, a parallel beam of light after reflection from a convex mirror appeared to diverge from a point behind the mirror. This point is called the principal focus of a convex mirror. It is a virtual focus because it is behind the mirror. You cannot get an image there, you can only see the image. So convex mirror, the focus is behind the mirror. Concave mirror, the focus is in front of the mirror. This is a real focus, this is a virtual focus. So once again, a parallel beam of light close to the principal axis after reflection from the convex mirror appeared to diverge from a point behind the mirror. This point is called the principal focus of a convex mirror, it is a virtual focus. Now let us explain focus of both the mirrors combined together for this. A narrow parallel beam of light close to the principal axis after reflection from the concave mirror converges to a point on the principal axis. This point is called principal focus of a concave mirror. A narrow parallel beam of light close to the principal axis after reflection from the convex mirror appear to diverge from a point behind the mirror. This is called the principal focus of a convex mirror. This is a virtual focus. This is a real focus. But for convex or concave, this property is obeyed r equal to 2f. You can take this property for both. R equal to 2f is true for convex as well as concave. Up to this, 10b, the class in live classes, we have seen up to this in the classes. Now this is a revision, take it as a revision. Now go through the textbook and find and see whether you are able to learn. If you are not thorough with it, you can put the questions regarding this in WhatsApp group, or you can call me and you can clear your doubts. No issue. Anytime you can call. But before the next class, you have to learn all these things. Now let me pass a little bit. Now what we are going to study next is image formations by a convex and concave mirror. Image formations by a convex and concave. Very important. Image formations by a concave mirror. Image formations by a concave mirror. Now, this you have to learn as a chart. I draw a concave mirror here. This is pole, focus, center of curvature. Now let me explain it first, then I will draw the diagram. When the object is far away, we call it as infinity. We call it as infinity. Infinity. When the object is very far away, after reflection it converges to the focus we know. So the image is at focus. Okay? Object infinity, image is formed at focus. Object beyond C means somewhat here. Object beyond C, image is formed between F and C. Image will move away from wherever. Object is at center of curvature, image is at the center of curvature. Object between center of curvature and focus, image will be formed beyond the center of curvature. Object at the focus, image is formed at infinity. Object between C and F and P, focus and pole, image is formed behind the mirror. Once again, object at infinity, image is formed at the focus. Nature I will explain. Object beyond C, image will be between F and C. Image will come away from the mirror. First of all, it is at focus. Now it will come away. Object beyond C, image between F and C. Object at C, image at C. Object between C and F, image beyond C. Object at F, image is at infinity. Object between F and P, image behind the mirror. I will write it here, one by one. You look at the textbook, position of object. Please just see whether how far I can go in this board, please. Please, hello. Please just see how far I can go on the board. Up to this? Up to this? Only up to this? Okay. Then, our position of object here, up to this, here, okay. So I will start from here. Object position, Columns, you just go to the textbook. Image position. Image position. Then size of image. Size of image. Nature of image. Nature of image. Object at infinity. At infinity. Object at infinity. Image is at focus. At F and focus. What is the size of image? Highly diminished image. Highly diminished image means so small. Point size. Point size. Point size image. Highly diminished image. Point size. Then the image is real and inverted. Real and inverted image. Okay. Next. Object beyond C. Beyond center of curvature. Image is formed between C and F. Between F and C. Between F and C. Diminished image, not point size. Diminished image. Diminished image, not the point size, diminished image. Then real and inverted. Real, inverted. Then at C. Image is formed at C. Same size. Object and image of the same size. Next it is real and inverted. Real, inverted. Real and inverted. Then between C and F. Beyond C. Beyond C. Enlarged image. Enlarged image. It is enlarged image. Real and inverted. Real inverted image. Then can I write here? Here. Okay. Then between C and F. Object at F. Image at infinity. Image at infinity. Enlarged image, highly enlarged image. That will be the highly enlarged image. Right? Highly enlarged image. Real and inverted. Real and inverted. Last one. Between F and P. Focus and pole. Image is from behind the mirror. Only position. Behind the mirror. Behind the mirror. The image is enlarged image. Enlarged image. It is virtual. See the difference? Virtual and mirror. The only position at which a concave mirror forms a virtual image when the object is between F and P. Can I write here? You can see something. Can you see the board here? Okay. Then I will draw the diagram here. Not all the diagram. A single diagram for your reference. This is concave mirror. Principal axis, pole, focus, center of curvature. See the first one, object far away infinity, the image is formed at the focus. See, highly diminished image, point size, small point sized image. Next, what is the nature? Image is real and inverted. You can focus it on the screen, but inverted image is obtained. Next one, image the object beyond C, close to C. Okay, not far away. Beyond C, the image is formed between F and C, between these two. You will get a diminished image, small image. It is real and inverted. inverted image but can be focused on a screen. Object at C, here you keep an object and you get the image here itself. When the object is at the center of curvature, you get an inverted image here itself. See, image is at C, same size, only position, where you get same size, real and inverted. Object between C and D, between these two, image is beyond C. Object between C and D, you get an image beyond C here, beyond C. Enlarged image and real and inverted. Object at the focus means if the object is here, at the focus, image is formed at infinity, far away infinity. Image is formed at infinity, highly enlarged image, real and inverted. When you keep the object between F and P, between focus and pole, you get an image behind the mirror. Means here, behind the mirror. And it's an enlarged image, virtual and image. Like this. It will be a large image, it is virtual and erect image. The only position where a concave mirror forms an erect image is when the object is kept between focus and the pole. You go through the chart in the textbook and study it well. This is very important before drawing the diagrams. This is very, very important. Object at infinity, image, object at far away infinity, image is formed at the focus. And it is highly diminished image, small one, point-sized image, real and inverted. Object beyond C, image between F and C, here it is formed, between F and C, it is a diminished image, real and inverted. Object at C, image is formed at C, same size, real and inverted. Object between C and F, image beyond C, image beyond C, an enlarged image, real and inverted. Object at the focus, the image is formed at infinity. It's a reverse process. Object infinity, image is focus. Object at focus, image is formed at infinity. Now, object between focus and pole, between these 2 points, you get an image behind the mirror, enlarged image, virtual image, erect image. It's an erect image, in a highly enlarged image, you get enlarged image. These positions you should make thorough before we draw the diagrams. Everything must be thorough. These points you have to study well. So what I am thinking is, next diagrams will be drawing in the next class. I will draw it on the board and make ready for you in the next class. And you come prepared with this chart. Learn everything, come prepared. Let us conclude today with some points, starting from starting point. What we learned is reflection. When light gets reflected from a plane mirror, it obeys 2 laws, what we call as laws of reflection. One is the incident ray, the reflected ray, and the normal should lie in the same plane. The angle of incidence equal to angle of reflection. Now what are the properties that image formed by a plane mirror obeys? 1. The object distance and the image distance are equal. Number 2. The image undergoes lateral inversion. Hope you remember. Your left hand will appear to be the right hand, lateral inversion. Number 3, the image is virtual, means cannot be focused on a screen. The image is virtual and the image, size of the image is same as the size of the object. These are the properties we learned. Now, what is a spherical mirror? A mirror which is a part of a sphere is called a spherical mirror. Concave and convex mirrors are commonly called as spherical mirrors. A concave mirror like this, concave mirror, the concave side reflects light, and the convex mirror, the convex side reflects light. Now both will be part of a sphere. The center of the sphere in which the mirror is a part is called as the center of curvature. The radius of the sphere in which the mirror is a part is called the radius of curvature. The geometric center of the reflecting surface is called as the pole of the mirror. A line drawn from pole to center of curvature is called as the principal axis. These are the terms we learn. Distance from pole to center of curvature is called as radius of curvature, represented by capital R. These are the points we already learned. Now, what are the definitions for the focus of principal focus of a concave and convex mirror? A parallel beam of light close to the principal axis after reflection from the concave mirror converges to a point on the principal axis, that point is called the principal focus of a concave mirror. It's a real focus. You can get an image. What is the focus of a convex mirror? A parallel beam of light close to the principal axis after reflection from the convex mirror appeared to diverge from a point behind the mirror. That point is called as the principal focus of the convex mirror, which is a virtual focus. For a convex mirror, always the focus is behind the mirror. The parallel beam of light appeared to come from this point behind the mirror. So focus is behind the mirror. It's a virtual focus. For a concave mirror, the focus is in front of the mirror. It's a real focus. You can get an image here. You cannot get an image here. Only you can see the image, what we call as a virtual image. Okay. This you learn. Now for both the mirrors, a common property is obeyed. What is it? Radius of curvature is always twice that of focal length. If the focal length is 10 cm, the radius of curvature will be 20 cm. Both for convex and concave, this is true. Now coming back to the various positions, next class I have to thorough with these ideas, then only I can draw the diagrams, ray diagrams to show how these images are obtained. Object far away from infinity, far away at infinity, image is formed at the focus. Here, image is formed at the focus. Size of the image is highly diminished image. Point size will be very small size. Highly diminished image. Nature of image, it's a real image. All are real and inverted. Only one image is virtual. Others are the same, real and inverted. Object beyond C here, image is between F and C. It's a between F and C. Diminished image, real and inverted. Object at C here, image is formed at C, same size, real and inverted. Object between C and F here, image is formed beyond C. Enlarged image, real big image, enlarged image, real and inverted. Object at the focus, image is formed at infinity. You think it like this, object at infinity, image is formed at focus. Object at the focus, image is formed at infinity, reverse way. At the focus object, you keep the object at focus, image is formed at infinity, highly enlarged, you see the difference, highly enlarged image, real and inverted, object between focus and pole, here, focus and pole, you get an image behind the mirror. Behind the mirror, it's an enlarged image, huge image, enlarged image, it is virtual and erect. It's an erect image and its virtual means it cannot be focused on a screen, only you can see. Cannot be focused on the screen. Now regarding concave mirror, only convex mirror, only we have two positions only, image positions two. When the object is far away infinity, image is at the focus, same idea. Object for convex mirror I am thinking about, object infinity, image is formed at the focus, but behind the mirror, focus, it will be, what kind of image will be formed? It is a diminished image, highly diminished image, point size image. But it's a virtual image. It is virtual and erect. That is a property, convex mirror. Object at infinity, image is formed at the focus, highly diminished image, virtual and erect image, Now, for convex mirror, object anywhere else, only two positions. If you keep an object here, anywhere, not at infinity, you will get an image between focus and pole. You get an image between focus and pole like this. Focus and pole, and image will be diminished image, not highly diminished point size, it's a diminished image. What is the nature? The nature will be, it is virtual and erect, always virtual and erect. So these are the two positions only for convex mirror. Object infinity, image is formed at the focus, the image will be virtual and erect. Now, it's a virtual image behind the mirror. Object anywhere in front of the convex mirror, not for infinity, the image is formed between pole and focus. We will draw it and show the image will be diminished image. It is erect and virtual. So these are the two positions for convex mirror. Everything, all these properties will draw and show the image positions we will locate by drawing. We call it as ray diagrams. Next class we will do it. So what I can do is I will draw all the diagrams on the board and will explain with the help of this diagram. That will be more convenient. Have a pleasant day.